So in this problem, we've got a small ice cube that is approaching a inclined ramp at rest, and it says that everything is frictionless, and the cube then slides up the ramp to reach a maximum height and then slides back down. So the first thing we're going to do is find the speed of the ramp when the cube reaches its maximum height, and this is a collision, so we can have conservation of momentum here. P initial equals P final. The ramp is at rest, so the initial momentum is just the mass of the ice cube times V naught, and then the final momentum is the combined masses times V final. And so all we have to do is solve for V final, and that is equal to mv naught over 6m, and that gives us v naught over 6. So for part B, it says find the maximum height to which the cube rises. So in this scenario, we know that as the block is going up the ramp, it's still at the bottom, but once it hits the ramp, it starts at an initial velocity of v naught. And so we can start with conservation of momentum. We're going to say it's still at the bottom of the ramp, but it has kinetic energy. And then as it goes to the top of the ramp, we know that both the ramp and the block are moving. And so that's going to be some gravitational energy and kinetic energy. And this is conservation of energy. They equal each other. So in this scenario, my initial energy is just of the block. And the velocity initial is just v naught squared. And then when it reaches the top of the ramp, we have the height, which is mgh plus the kinetic energy of the two blocks moving together simultaneously. So the block is at a gravitational height, but the kinetic energy is of the cube and ramp system. So that's 1/2 6m, because I'm adding those masses together, times the velocity I got from part A. So that's v naught over 6 squared. So we're going to start simplifying this down. My m's can divide out completely. I have this v naught, which if I distribute the squared, it'll be v naught squared 6 squared. And then I have one of these 6's in the denominator, cancels out with this 6, and I get v naught squared over 2 is equal to gh plus v naught squared over 12. And then what I'm going to do, because I don't like working with fractions, is multiply everything by 12 on both sides. So I end up with 6 v naught squared is equal to 12 gh plus v naught squared. And I subtract the v naught squared over to get 5 v naught squared is equal to 12 gh. And then my final answer for h is equal to 5 v naught squared over 12g. And that is going to be the height that the block reaches the top of the ramp. So for part C, it says find the final speed of the ramp when the cube returns back to the horizontal surface. You can try to use conservation of momentum for this, but you're going to find that you have too many unknowns. So if we think about this scenario, the block is going to collide with the ramp, move up to the certain height, and then move back down. So even though it might seem like it's inelastic because the block moves up the ramp, they end separate. So you can really think of this as an elastic collision once they separate. And we can use our memorized equation of, since we're trying to find the ramp, I'm going to call this object 2 and object 1. So I'm going to start with the V2 final equation is equal to 2 m1 over m1 plus m2 v naught plus m2 minus m1 over m1 plus m2 v2 final. This is I should adjust this because this is v1 final, and then I can, I'm messing this up. This is v1 initial and this is v2 initial. And then I can substitute the appropriate values next. So first of all, v2 is equal to 0. So that is the initial velocity of my ramp. And so that all cancels out. And then when I plug in my values, v2 final is equal to 2 times m1, which is just m. m1 plus m2 is m plus 5m. And then v1 is the initial velocity of my cube, which is v naught. And then that all simplifies down to 2m over 6m v naught, which is v naught over 3. So the last step is to find the speed of the cube when it returns to the horizontal surface. I'm going to use the same equation for the cube, except this time I'm doing v1 final is equal to my m1 minus m2, so that's m minus 5m over the sum of those masses times v1, which is v naught, and then the second part is 2m over the sum of those masses times the velocity of my ramp, which is 0. Again, that cancels out. And v1 final is equal to negative 4m over 6m v naught, and that reduces down to 2/3 v naught. And it should be negative. So that is my final answer for D.